Hi, everyone. I'm Travis, and in our DevOps part, I'm going to give a brief introduction of the structure for the tasker coming CRM. So in this part, Gary will talk about the Terraform. Joe is going to introduce CI/CD pipeline and monitoring part. In this project, we have used the single region three-tier architecture, which includes presentation, data, and logic. The presentation tier is the front-end layer, which is served by the AWS S3 and the CloudFront. Our team used Route 53 for domain names and wrote end users to the app. So basically, S3 for the static contents and CloudFront for each location caching, helping to decrease the latency to deliver content to our users. It also worked well with the AWS Certificate Manager to provide an encrypted connections for the app. The application is implemented as ECS target test span across two availability zones, which deployed in a private subnet to ensure security. A NAT gateway is attached to connect outbound traffic because the private subnet does not have direct access to the internet. Because of that, the tasks are able to send logs to CloudWatch and request ECR images. A load balancer was deployed in order to allow traffic from public to reach containers. Users can access load balancer and also forward the request traffic to the container task. Moreover, each target task is attached to an elastic network interface. The IP of the network interface is added to the load balancer's configuration. In our project, the configuration here we use can make sure our application containers to be safely isolated from the public internet. And they are also capable to initialize communication with external resources through NAT gateway and still be able to receive traffic from the public through the application balancer. Meanwhile, the application load balancer and Faggot task send logs to CloudWatch, which can be imported to Grafana for monitoring and alerting purposes. For the data tier, we use MongoDB Atlas. We have used a separate database for UAT and production environments. The stream was added to the secret manager for secure connection. Next part, my team member Gary will give information about Terraform.
Thanks, Doris. So my name is Gary, and I'm mainly responsible for configuring our Terraform code in the team. So before everything starts, I would like to give a brief introduction about infrastructure as code, IAC. So the tool we use here is Terraform. So Terraform is an open source tool for managing cloud infrastructure using declarative configuration files. It allows for efficient provisioning, versioning, and collaboration on infrastructure resources, also promoting consistency and reducing human error. So in our use case, we utilize the power of Terraform by developing our code with modules and using workspaces for different environments. Specifically, we have two workspaces, UAT and production, that allow us to efficiently manage our infrastructure for two environments respectively. So on the front-end side, we have automated our deployment process by detecting the current workspace using environment variables, which is terraform.workspace. So depending on the workspace, our Terraform code will adjust the configuration accordingly. For our backend infrastructure, we use count and workspace to generate two identical infrastructure for UAT and the production environment. We also use Terraform Cloud to enable remote backend management of our state files and state logs. Additionally, we can implement advanced features in Terraform Cloud, such as cost estimation and the user interface to promote a more collaborative environment. Overall, our approach to using Terraform is highly efficient, automated, and allows us to easily manage our infrastructure across multiple environments. Yes, so that's all my part of Terraform, and Joe will give some more insights of our CI/CD pipeline. Thanks.
Thanks, Gary. Hi, everyone. This is Joe. I'm going to introduce our continuous integration and continuous delivery pipelines in our project. We implemented CI/CD pipelines to support our development team automatically test and deploy code to achieve agile methodology. Initially, we used Jenkins as our pipeline tool since it is an open source and widely used tool in the market. We set up master and slave node architecture for high availability and efficiency. We also used multi-branch pipeline to have different environments for different branches. After investigation of GitHub actions, we successfully decreased operation cost by migration of Jenkins to GitHub actions. In the front end, a pull request triggers CI workflow to install packages and perform required tests, and CodeQL analyzes code vulnerabilities. The check detail will be showed in each pull request page to enhance developers' experience and efficiency. Once CI passed, the merge triggers CD to install packages and build artifacts, then deploy to S3 bucket. Finally, we invalidate the S3 objects to update CloudFront cache and serve newly updated content to our users in time. In the backend pipeline, a pull request triggers CI workflow to install packages and perform required tests and code analysis. Then the merge triggers CD to build Docker images and push it to ECR private registry. We also use ECR image scanning to double-check vulnerabilities of our Docker images. After that, we update ECS service to run new containers. Next, please. Our Terraform code is automatically deployed with workflow as well. In CI, it scans our Terraform code by TerraScan to detect vulnerabilities and mitigate risks before provisioning cloud resources. Then show the Terraform plan result in the workflow logs. The merge triggers CD to perform Terraform apply for resource deployment, and we set AWS access keys as secrets in GitHub actions for security. Next, please. Monitoring and logging are essential in modern software development. Good monitoring helps early detection of issues, and logging perform root cause analysis of issues. We used CloudWatch dashboard to monitor CloudFront, load balancer, and ECS. And we applied 4 golden signals, including traffic, latency, errors, and saturation. Next, please. And we also used Grafana for better visualization and alerts us when metrics reach thresholds. Next. We used CloudWatch log insights on ECS backend to support troubleshooting and performance optimization for developers, and the CloudTrail provide us audit trail of user events and API calls for better security and account management. Thank you.